Hey, hello, Mr. Yeager for Honors Chem. We are looking at percent composition now. So moving a little bit away from the mole conversions and everything like that to another thing that we generally calculate during this unit is figuring out the percent composition of a compound, which this is again very, very common in environmental science, environmental chemistry, where people are trying to find pollutants or trying to find impurities or quality control. We want to know the percent composition of the compound so we know that it's what it should, or we're trying to represent it to be. Okay? So, this is fairly quick. All right? You basically are just needing to use molar mass. All right? We're going to find the percentage by mass of each element based on molar mass. Okay? So, basically what we got here is 3 steps we're going to do, and I'll show this as we go through it. Okay? Step 1, find the molar mass of the compound. Okay? Nothing different there, nothing special. Find the molar mass. Okay? Add up the molar mass of one of the elements. Okay, what I mean there is, if you only have one element, you have it and you're good to go. But if you have like 2 chlorines, make sure you combine those 2 chlorines for the total mass of that element in the compound. Then basically divide the molar mass of that element divided by the molar mass of the compound, and then multiply by 100, and you'll get percent composition. Because it's a percentage, we should hopefully have everything add up very, very close to 100. It is common, based on rounding, that we might get 99.99 or 100.01. That's okay, but that's again a good way to check everything. So here we go, straight to the examples. Okay. So I have this element right here, C2H6. First step, find the molar mass. Okay. We got 2 C's, 12.01 times 2, and we got 6 H's. 6 times 1.01. Okay, so I want my calculator, even though I could probably do this in my head. 24.02 and then those, but 12.01 times 2 plus 6. We get 30.08. Okay, grams per mole. So that is the molar mass of my compound. CPD again is my abbreviation for compound. Okay, then what I do is, this is not usually a super difficult problem. It just generally takes some time. We want to find the percent composition of each of these elements. What's the percent of the compound that's C, and what's the percent that is H? So what I do is I get the total mass of C, which is both of these. The mistake people run into is people will plug in 12.01. All right? There's 2 of them, so the total mass of C in the compound is 24.02. I divide that by the total mass of the compound, and then I'm going to multiply that by 100. And then I do the same thing with hydrogen. 6.06 divided by 30.08 times 100. Okay? Now, I'll come back to that in a second. 24.02 divided by 30.08 times 100. All right. We're going to go off of basically the sig figs of the molar masses in this case. We don't go off the 100. So this is 79.85%, and that means and this is the thing, I could go ahead and calculate this out, 6.06 divided by 30.08 times 100, and guess what? It comes out to 20.15, what a surprise. Clearly, if you already know one element and there's only 2 elements in it, you could just subtract 100 from this and get the other element, that's fine, okay? That's okay, that's okay, that's okay. You can actually calculate it if you want, but you don't have to, okay? But that's basically it. You find the molar mass, do the total mass of the carbon in the compound, divide by the, by the compound itself, and then do the same thing, or just subtract from 100 to get the other one. And that's all we get, percent, okay? Let's do one where there's 3 elements. Let's see if we find one. There we go. Oh, 4 elements, okay? We'll end with this one. So we got sodium, what is this? Hyposulfite or something like that? I don't know. No, it's not that. Bisulfite? I don't remember. Shoot, I should know my polyatomics better. So let's get this started. Na, just one of them. Na is, I'm out of practice, I should know that. Actually comes out to 23, rounded, 23.00. Whoops, too many zeros. Got excited. Hydrogen is 1.01. Sulfur, I'm pretty sure, is 32.06 or 7? 7. And then I got 4 oxygen, so 16.00 times 4. So that's the only one I have to actually multiply out. So 23 plus 1.01 plus 32.07 plus 64. This all comes out to a total mass of 120.08 grams per mole. Now we should be able to kind of look at this and go, which element will have the highest percentage? Which one will have the least percentage? And it's not always just based off of how many atoms there are. You do have to be careful there. In the end, yes, oxygen will have the most. Is it the heaviest element in the compound? No, sulfur is the heaviest, but there's more oxygen, so it obviously overtakes the sulfur. Okay? But then all I do is I kind of go through each one. Percent of Na will be 23 divided by 120. I'll put the 00 there. 0.08. Percent of hydrogen will be 1.01 divided by 120.08. I do percent of the sulfur, 32.07 divided by 120.08. And I'm not going to do it with oxygen. I'm going to just solve for the other ones, and I'll figure out the percent oxygen based off of that. So 23 divided by 120.08 is 19.15%. 1.01 divided by 120.08 is 8. I forgot to multiply. 1.01 times 120.08. Oh my gosh, sorry. 1.01 divided by 120.08 times 100. This actually comes out to 0.841. And then 32.07 divided by 120.08 is 26.71. I'm going to just add all of those up. So that's percent, percent, percent. And some people might be like, isn't it faster just to put 64 divided by 120? Probably. But I'm going to do it this way. 19.15 plus 0.841 plus 26.71. Again, I'm going to round it off because I'm going to kind of follow my sig fig rules where you have to round it off to the shortest decimal. This totals 46.70. So then I subtract 100 from that because it has to all add up to 100. And my oxygen is 53.3%. And there you go. Oh, 30%. Actually comes out exactly that way. All right. Yep, it'll come out that way. And again, you could double check and it'd be like 53.3 plus 26.71 plus 0.841 plus 19.15. It came out to 100.0001. Everything's wrong. No, we obviously just kind of ignored that last one there. We rounded that one off. Okay, so that's basically it. That is percent composition. Pay attention to just calculating out the molar mass, and don't forget to make sure to add all of the atoms of a particular element over the total compound mass to get the percent composition.